after the question and answer is 5 minutes. 5 minutes?
Yes, sir. Yes, sir.
Yeah, okay.
Thank you. So, good afternoon, everyone. Good afternoon to the dignitaries present here and co-participants who are being present here to present the paper on several topics. So, my topic is on about an investigation on microstructure evolution and mechanical properties of zinc coating, which is acting as an interlayer on magnesium aluminum alloy using diffusion bonding. So, our authors are Golden Ranjit Nimal, myself Chandil, Sanga Mageshwaran R, Hariharan R, and S.A. Mittal. So while going on an abstract, diffusion bonding, it is a process of joining two or more dissimilar materials, where the materials are being kept under several pressures with respect to some temperature and for a specific time. During this period, the atom gets diffused between themselves and between these two metals across the interfaces, and the material transformation occurs between one material to the other material. The traditional method of fusion state wetting is having some disadvantages, such as the production of less heat affected zone, as the process is obtaining with respect to the temperature. It is having some less affected heat zone than dissolution of the base material. Here in this investigation, we are used a material of 4 series aluminum 7075 and magnesium alloy of AZ880 alloy, which has been combined with respect to the effect of holding time and holding temperature to diffusion, and here the studies have been done under the mechanical and the metallurgical properties of it. Zinc coated magnesium combination and 4 series AA7075 aluminum amalgam have been treated under the diffusion bonding. Temperature ranges has been taken from 350 to 450 degrees Celsius, and the pressures of 2 megapascal to 25 megapascal has been taken here, with an holding time which has been required for the process is of about 5 minutes to the 150 minutes. It's resulting between the zinc coated AZ80 magnesium and AA7075 aluminum. After the experiment, during the experiment, we have taken a temperature of 350 to 450 degrees Celsius and a bonding pressure of 2 megapascal to 25 megapascal, which resulted a dispersion between the zinc coated materials of magnesium and aluminum alloy. So next is the introduction. What is an diffusion bonding? So it is a solid state welding process. When compared to the fusion welding, it is having some of the merits, as it is been having a different where the different materials are being integrated with respect to that thermal expansion and conductivity of very least importance.
Mr. Kumar, Mr. Please, you can straight away you can go to the
my experiment
as well as objectives.
Okay, sir. I'll move on it. So these are the chemical compositions of materials, magnesium alloy and aluminum alloy, varying with respect to the percentages which we are using here. This is all about, first one is about the magnesium and second is all about the aluminum. And this is the mechanical properties. So as the experiment consider here, we have used material of size 45 to 45 with a thickness of 5 mm for 5 mm is being used a thickness for aluminum, and 10 mm thickness was used for the magnesium. It has been kept under a furnace structure. I'll just show this. This is the die setup. This is the bottom plate, is the top plate, and the middle plate, where the specimen is kept here under several load is been applied. That load been considered in the pressure area, and it is been kept under for several time, which I have mentioned earlier. And in furnace, it has been maintained with respect to the temperature. So this is the base material we are used here. The aluminum is mixed with respect to 5.1% of zinc and 2.1% of magnesium and 1.2% of copper. Whereas this magnesium is a properly silver made material, which is an alloy of 8.36% of aluminum and 0.75% of zinc, which is a non-ferrous alloy. Both compositions are acting under the welding vacuum spectrometer, and the whole setup is being kept under the diffusion bonding setup. Then temperature were assessed using the reasonable platinum thermocouple, which has been protected outside, and the chiller was equipped with a separable robot and a focal bar, which has been kept outside for gaining the what is the process temperature or as well as pressure and as well as the time to be noted out. Then the size of the room maintained within the area is all about 100 mm, and the height is all 100 mm. The prepared sample were heated at 25 degrees Celsius, and that concerned weight after the docking was applied, the model has been cooled at a room temperature and removed from the chamber. After the application of this was the result we have achieved here. The first column is all about the bonding temperature which we have used here. Second is all about bonding pressure. Third is all about bonding time. From this, we have achieved a result of lap shear strength and ram tensile strength. So as in the first 1, 2, 3, and 4, we can see that we have varying the temperature. We are varying the temperature from 325 to 400 pressure, 400 degrees Celsius. Here we have kept the pressure 10 megapascal as a constant and bonding time as a constant. Whereas for 325 we have not achieved a bonding structure. So it was considered for that we have to increase the temperature from that. So we have to increase the temperature to 350, from which we have achieved a lap shear of 14 megapascal and ram tensile of 17 megapascal. When it is been exceeded from 350 to 375, and when it reached 400, again there we have not seen any bonding occurred. So we have taken this 350 and 375 as a minimum and maximum range for the bonding temperature. As we go on for the effect of pressure, here we have given the pressure we are varying. We are varying the pressure here from 2 megapascal to 25 megapascal by keeping a constant temperature of 375 and the bonding time of 15 minutes. As again for effect of time, we are varying a time from 2 minutes to 60 minutes by keeping a constant of temperature as 375 and pressure of 10 megapascal. From that, we have achieved a lap shear strength and a ram tensile strength of these amount. Right? From this is the sample which we have done, and this is the sample which we used for tensile strength, and this is for the ram tensile strength. Here, the tensile strength indicated that the weld quality can be exceeded the final elasticity of the model base, from which the base material which caused a disappointment that the bonding was very weaker at the area where the base material indicated a failure in a trial sample 2. So as I showed in before tabular column, it has a failure in that. In the ram tensile, the strength measurement, a standard specimen was used to determine the bond strength, whereas a bonded plate with a hole, whereas the one side diffusion bonding and the larger side is on the was weaker than the other side. This made a testing fixture, and the ram pressure force makes the bond in the tension area. The sample test before the application of tensile force is shown with respect to the aluminum and magnesium alloy. So this is the final result which we achieved, this lap shear strength for a zinc coated magnesium alloy, comparing with respect to temperature, pressure, and time. About here we can see all about the at 375 degrees Celsius, the lap shear strength regarded was found to be connect with 21 megapascal. So this is one. With at an area of 375, we have seen a 21 megapascal. The lap shear connecting to the oblique was found about the expanding pattern from pressure of 5 megapascal to 5 megapascal, and it was all about the 22 megapascal. So from initially it was started from 5 megapascal and it reached all about the 22 megapascal. Whereas for the pressure of 20 megapascal, it was all about the processes of 30 megapascal. With respect to the whole temperature was maintained all about the 375 degrees Celsius, and the time duration was all about the 30 minutes. This was the temperature and the pressure maintained with respect to the result under the mechanical testing of it. And this is all about the metallurgical testing which we done under SEM. Here we can see the magnification of all about started from 100, 200, 500 and 1000 megapascal, 1000 magnification. And here we have achieved that the process which we done gave a one heated to 400 degrees Celsius, and the holding pressure was kept under the 10 megapascals under the 15% of reception which we achieved in the SEM result. And this is the whole this is the zoomed picture of it, where the material transformation from magnesium to from aluminum to magnesium, it occurred in the percentage of 40 is to 60 ratio. This indicated area we can see some of the cracks which we find with respect to the SEM images. This may convincingly be because of deficient heat information and a short information time with respect to the tube edges. We call it as a tube edges, which will be bulged with respect to the break occur at the little time, and the cleavage because of the fracture and weakness might be because of the stream design here. Then from the as I mentioned, it was all about the 40.
You speed up your work.
Sir?
Yeah, please speed up.
Yes, sir. It is all about 40:60 ratio, as I mentioned. So due to the formation of intermetallic voids are created between the bonded joints, and with respect to the carrying out the mechanical investigation, examples such as hardness, trials of smash and cracks were found. So we have concluded that the magnesium and aluminum with the zinc coating as an interlayer was successfully done by the diffusion bonding, and this coating layer is added as an improvement for mechanical properties of welded joint, and an optimum parameters to forecome or do this experiment was maintained as about the 375 degrees Celsius under 20 megapascal, and 15 minutes was the higher value at which we can achieve the bonding property. And RAM tensile exhibits the higher strength in the same parameter, whereas the cleavage because of the crack and fragility, as I showed you in the last image, the vary with respect to the waterway as a passage of waterway design, which has been seen in the above same image. So these are only some of the references which you have used here. That's it, sir. Thank you. That's it, sir.
Okay. Thank you, Mr. Sandil. Any questions from the audience? 5 minutes allowed for that discussion.
Sir, I have a small clarification, sir.
Yes, sir. Yes, sir.
Yeah, Sandil, sir, tell me the application for this.
Sir, properly it has been
where you have to use in the industry.
Aircraft application, sir. It has been used for
weight base. How much weight?
Sir, weight is when compared to the materials available here, available such as titanium and other inconel materials. This is also somewhat equalized to the materials, sir. These materials are also used with respect to the wing blades and for spoilers and flaps.
What about the cost? Based on the cost,
it is less than the present material. Present materials such as titanium, when compared to titanium, this magnesium and aluminum are somewhat less than the present materials.
Okay, sir. Okay. Okay, thank you, sir.
Thank you.
Okay. Now, Mr. Sandil, I have some small queries.
Yes, sir. Yes, sir. Yes, sir. Please.
What is the novelty you are claiming in your work?
Sir, with the presence of interlayer when compared with respect to the without interlayer, the zinc has been placing a high task and high factor with respect to mechanical and metallurgical properties of the material.
So, in your diagrams, you have not mentioned the specimens detail. You have given two specimens, no, in your not first one, the schematic.
This one, sir.
Specimens you have mentioned. What specimen is placed top and what specimen placed in bottom?
Sir, this is a die setup, sir. This is a die setup where we are going to place the specimen at the bottom. This will be the top. This will be the top plate, sir, and this is the bottom plate. By applying a pressure with respect to these.
Yeah, that is understood from the diagram.
Sir. Yes, sir.
But you have to mention which material going to place in bottom and which place is going to first, and why it is placed like that. And you have to give the justification for the placing of materials in bottom and placing of it in upper side, and also the selection of the interlayer material. Okay.
Sure, sir. Sure.
Zinc material. Is it, and that is why you have selected particular material?
Okay, sir.
Any reasons?
Sir, zinc was for better coating. Zinc has been used as a better material for coating purposes, better than nickel. Nickel coating, zinc coating is better material for as related to magnesium and aluminum. It is giving a higher mechanical property, sir. And with respect to the material which we have selected here, magnesium and aluminum, as the just a minute, sir. I'll just show you the property of it. As here, when compared to magnesium and aluminum, zinc is having somewhat less property present in the material. So we have use the zinc here, neither than the nickel. So that
Less
is what.
property means you are specifically you have to point out which property is less.
Okay, okay, sir. I'll
Okay.
note it down, sir. Okay,
In
okay, I'll note it down, sir. Sure, sir.
general
I'll note it.
terminology, don't use. In research findings, you have to specify the what purpose, why it is happening, and what basis you are selected. Similarly, you the temperature and bonding pressure and all. You have not mentioned what basis you have selected the bonding time and pressure.
Based on the several references only, we have done it, sir.
That and all you have not mentioned. You have to mention the further research.
Sure,
Okay.
sure, sure,
Okay,
sir.
thank you, one and all. I hand over to Mr. Dr. Selvakumar.
Okay.
Hello.
Yes, sir.
Yes, sir. What about the heat transfer, sir? Compared to using for aerodynamic aeroplane applications,
Yes,
what
sir.
is the based on the heat transfer? Will
Sir,
be
yes, sir. I'm not audible, sir.
yeah.
Sir, your voice is
Yes,
not
sir. Yes,
clearly
sir.
audible.
Oh, in terms of heat transfer capacity,
Okay, sir.
what about the um, this magnesium is useful for? It will be conducting more amount of heat or reducing the heat transfer rate.
Sir, that is what, sir. At last, the mechanical, the transformation is all about from 40 is to 60 percentage, sir. As 40
Okay.
percentage of aluminum is been transferred to
Hmm.
60 percentage of magnesium, sir.
Okay. Okay. Hmm. Okay, sir. Well done. Thank you, sir.
Thank you. Thank you, sir.
Okay. Shall I proceed to next candidate, sir?
Yes, sir. Sure, sir.
Yeah.
Sir,
Next candidate, allow the next candidate to present.
Okay, sir. Uh,
sir, I will stop my presenting, sir.
Yeah,
yes, yes,
okay.
yes.
Thank you. Thank you.
Shankari, madam, please present next. Shankari,
Sure,
madam.
sir.
Okay.
Yes, sir.
Share your presentation, ma'am.
Okay, sir.
Hello, am I audible to
Yeah,
everyone?
you can proceed. Time is very
Good afternoon
precious.
to one
Please
and all present
keep
here.
it.
The name of the sorry, sir.
Yes, carry on, sir. Carry on.
Your
Proceed, proceed,
presentation,
proceed.
please.
Am I audible?
Yeah, you are audible. You
Is it
speed
visible,
up
sir? It
your
is being
work.
presented.
Yeah, okay.
Oh, okay, sir.
Everything is okay. You can proceed.
The paper we are going to present is experimental analysis of the jet flow in an air spike nozzle. When you are today, the present day, the CD nozzle is being used, but in the multi stages only the operation is being conducted and the rockets are also being launched. In order to eliminate this multi-staging process, we have come up with multi-staging. Uh, in order to avoid this multi-staging, the aerospike nozzle can also be used as an altitude compensation nozzle. The objectives are to experimentally analyze an aerospike nozzle with off cone angle of 15 degree with in order to reduce the centerline pressure decay at the exit of nozzle. So this becomes an major upcoming in order to compensate the altitude compensation which is required for the multi-staging processes. We have also studied the shockwave and boundary layer interaction between the shock waves, and we also visualize the shadow graph method in order to determine the shock waves. The need of the experiment. Today, the majorly the CD nozzles, that is the convergent divergent nozzle, is being used in every rockets and other rocket propulsion also. So this is presently done by multi-staging process. That is below the within the sea level, the single engine, and when it comes to the atmosphere with vacuum condition, the other experiment, the other nozzle is being used. So in order to reduce this, the staging process into one, the aerospike nozzle is being used. So this also makes the cost of these experiment with very less compared to the both two convergent divergent nozzles, then replacing it with an one aerospike nozzle. The pressure decay is also being studied in order with the toroidal aerospike nozzle. Okay, can we go to the next slide, please? Comparison of aerospike nozzle with CD nozzle. The slide. Ms. Shankari, am I audible to you? Can you change the slide? The comparison of the aerospike nozzle with the CD nozzle. By if you come up with the CD nozzle, there are three kinds of expansions. First one is the over expanded, second one is the optimally expanded, and the third one is the under expanded. In the first figure, we can see that the over expanded region, where the atmospheric pressure at the ground level is very much higher than the exit pressure. So the exit thrust is being converged into single like a conical structure. We can see that the thrust is being compressed because the high pressure at the atmospheric level is being converging it to make it like a plunging slide. But when the atmospheric pressure and the exit pressure becomes equal or optimally equal, the optimally expanded condition is being occurring in the convergent divergent nozzle. That is the second picture. But when we come to the vacuum conditions, the pressure at the exit is very much higher than the atmospheric pressure because the vacuum levels are very much low. So the exit thrust is being overly expanded. This condition is called as an under expanded region. The thrust becomes enlarged, which reduces the thrust force and all. But we come to the aerospike nozzle, the below first one, the over expanded condition, when the atmospheric pressure is higher than the exit pressure, the thrust force, the exit pressure is being, the atmospheric pressure converges the exit of the nozzle to along with the shape of the spike. Because of this, the what we are contouring in the spike, we can achieve that shape in the exit pressure also. But by coming to the optimally expanded, the pressure becomes as same as that of the CD nozzle. But we coming to the under expanded region in the vacuum level. This is the most important part of this nozzle, where the exit pressure is very much higher than that of the atmospheric level. The force of the exit air thrust, we can say anything, but it tends to expand a little bit where the thrust loses. But in the aerospike nozzle, the spike is being very much influencing the factor of that expansion. The thrust force is being sliding over that of the spike only. So when comparing to the CD nozzle, the aerospike is being much more advantageous in comparing to the vacuum level. The advantages is that the multi-staging can be completely eliminated by only using a single nozzle. This makes the sea level and the vacuum level engine, that is the compressors, the nozzles, to be integrated into a single nozzle. It also consumes approximately 25 to 30% of fuel at the low altitudes, where the boosters can be less fuel consumptions. the performance of the nozzle is being very much higher than that of the CD nozzle. By reducing the pressure decay to a very small range, the high velocity in the nozzles can be achieved in a very quicker rate. When you come to the methodology, the problem of this main concept is to eliminate the multi-staging drawbacks. So how can we eliminate by comparing? We got an air spike nozzle. So in order to design it, the specification must be uh, set first in order to design an arrow spike. Then if the specifications are required, the fabrication methods are being deliberated, and it is being consulted what are the methods can be used. After the fabrication, we need to test the specimen in order to get an active result of what we are being achieving. So after this, the optimization of the results can be concluded. When we come to the design calculation, that is designing of the arrow spike nozzle.
Please
The
speed up
main
your
thing is the exit
presentation.
pressure area.
Please speed up your presentation.
Sorry, sir.
Please speed up your
Yes, sir.
presentation.
That's also the design. Okay, sir. Yes, sir. Got it, sir. The exit pressure ratio, that is we are designing it to the Mach 1.5. So in order to design it, the area ratio of something of 1.17. This is being determined from the HMT data book. Next slide. The pressure of the exit is being calculated in the pitot. So in order to consider the pitot blockage ratio as negligible, the throat area of the nozzle to the pitot probe area the ratio should be greater than or equal to 64 in order to consider the pitot blockage as a negligible condition. By keeping in that mind, the trial and error methods, the areas of the exit and the output area pressure with the area ratio, we can have the outer diameter and the inner diameter of the nozzles. When we come to the design model, the arrow spike cannot be for our comfortability and our machinability. We have designed the arrow spike nozzle into 4 parts. First one is the adapter, the coupler in order to couple the spike in the position, and the cowl which gives the nozzle action. The material is stainless steel grade 304. This is being machined in a CNC controlled process with a high surface finish as much as possible. The parts are being given the next slide. When we come to the experimental setup must contain of an high pressure gas with the pressure regulating valve and a settling chamber. The settling chamber reduces the turbulence of the flow to laminar. We done the experiment at the pressure of 4 bar, that is the absolute pressure, with the pitot as a measuring device. We have can we move to the next slide with the measurement setup? The pressure enters at the settling chamber, and the settling chamber reduces to the laminar flow. So the required pressure range being set to a 4 bar, we made the experiment with the axis and the radial methods. The pitot measures the exit pressure with sensors, and the data is being recorded in the transverse mechanism at the x-axis, y-axis, with the help of the computer being noted. The further experimental analysis will be continued by a fellow mate, Ms. Shankari.
Good afternoon. I'll be explaining about the experimental analysis. In our experimental analysis, the pressure measurement is done in 2 directions with respect to the nozzle exit. Here is one of the video which depicts the central line pressure measurement from which we obtain the graph to measure the core region. I'll just play the video. The pitot is being moved in axial direction by means of a transverse mechanism.
Yeah, what results you find from this experiment? That is important. Please.
Okay, sir. The advancement we made from this analysis is that with the reference from the Journal of Ambient Energy, in which the CD nozzle with circular and elliptical throat is being carried out at nozzle pressure ratio 4. The constant measures we and the constant measure we took from the reference is the nozzle pressure ratio and the nozzle of on the nozzle design of Mach 1.5. We compared the results and we obtained a core region which is much shorter than that of the CD nozzle. The main aim to reduce the core region is to just attain the ambient pressure in a faster rate, which promotes the maximum velocity attainment quickly. That's the main thing we proved, sir. The scope of the project is that we have done the core region reducement. By means of this, it can be used in fighter jets, missiles, and in space industry, it can be used in suborbital launches for space tourism and for single stage to orbit launch vehicles. When the span of pressure decay is reduced, the velocity will be attained in a very faster rate, and it will be producing much less noise than that of the CD nozzles, and a single stage can be used for heavy launches. That's it, sir.
Okay, Mr. Santosh and Sankari, you have completed your work.
Yes, sir.
It's your BE project work.
Yes, sir.
So
Sorry,
from this is a project work results.
Yes, sir.
Yes, sir. This is a final year project work, sir.
Project work. From this work, what you concluded? What is your suggestions for the industry to recommend this type of?
The suggestions is that
Sir,
the aerospike nozzle.
Aerospike nozzle.
Okay, Shankari will continue.
So the suggestion will be that presently the CD nozzles have been used in a wide manner in multi-stage engines. But instead of that, we can use the aerospike nozzle with a single-stage propulsion system, which also reduce the, normally in launching purpose, there will be two costs. One is the rocket building cost, second one is the launching cost. By using the aerospike nozzle design and aerospike engine, both these costs can be reduced and the space market will increase to a larger extent in India, sir.
So you are giving this design. What percentage of improvement may be obtained the existing model?
Sir, as we've done as this project work, we have done in a very small scale size, so that we have, with the help of the reference, we have compared the aerospike nozzle performance and the CD nozzle performance as presented in the present slide. The CD nozzle, which has been designed for the same maximum Mach number 1.5, and our aerospike nozzle is also designed for 1.5 ratio, 1.5 Mach number. It is saying that the core region, the pressure,
No,
time
I'm,
which is taken.
I'm asking any design or any improvement, if available, we have to compare with the standard one, okay, or existing model. So if it is improvement is there, automatically everyone will appreciate and you can buy the product. So in that case, how much achievement you have achieved in this case?
So we have made.
So we did not compare it to the existing model, but we compared to the existing convergent divergent nozzle.
So in that particular case alone, you can give the performance.
Yes, that is being presented in the slide. So we can see that the 75 and 40 that the percentage is being reduced in order to 31.
Okay. Okay, I hand over to another.
Yes,
Yes,
sir.
sir.
Thank you, sir. Thank you. Yeah,
Thank you.
Santosh, very good presentation. Yeah, I have a small doubt. Mach number, how much Mach number, maximum Mach number achieved for your experiment?
So we designed it to 1.5, sir. So the maximum achievable is also 1.5.
Okay. And your rockets, normally, how much maximum Mach number?
Sir, rockets when at the stage of sea level to atmosphere, the rockets will be in subsonic and supersonic levels. At the stage when it enters to the atmospheric layers, at some certain point, the hypersonic speed will be achieved, sir.
Okay. You refer previous journals also?
Sir?
Yes,
Any
sir. We
previous
got many
journals?
references, sir. The references are being cited in the PPT.
Okay, what you took from the references generally? What are the data you have collected from the reference?
Sir, at the
For this,
starting, we took the reference from NASA reports. In
okay,
NASA reports, in aerospace nozzle, they have done the annular plug, that is same which we have taken in 10 degrees and 70-degree half angle.
okay, okay,
We
sir.
have done it looking
Okay, okay, Shankari, okay, very good, very nice presentation. This is your second conference or first conference?
Second conference, sir.
second conference.
Second, okay, sir. Sir, Senthil Kumar sir, Senthil Kumar sir.
Yeah, I'm hearing your
Yeah,
voice.
yeah, both of them our students, sir. Our department, SR only my
Yeah,
mechanical.
yeah, yeah. You can congratulate the students and also concentrate a higher level research in this
Yes,
area because
yes,
lot of openings are there.
yes, sir.
The,
Yes, sir.
so design aspects nowadays the people are not doing.
Yes, sir.
So that much you can incorporate all the latest software and using that and the
Yes, sir.
design aspects you can improve their research. Okay,
Sure,
and
sir. Sure, sir.
encourage the students.
Yes, sir.
Okay,
Yes, sir.
congratulate them and also their guide also. I think motivated the student in right way.
Yes,
And
sir.
also I convey the congratulations to you. Okay.
Thank you, sir. Thank you, Pa. Santosh. Thank you.
Thank you, sir. Thank you.
Thank you, sir. We will also like to thank HOD for giving this opportunity for us.
Okay, Pa. Okay. Welcome.
Thank you, sir.
Okay. Varavan, sir, please go for next presentation, sir. Varavan, sir.
Mr. Velan,
Sir, yes, sir. Sir.
yeah, please.
Dhanasagar, sir, kindly share your presentation, sir. Dhanasagar, sir.
So yes, sir. Good afternoon to one and all present here.
Yes,
I'm
sir.
Dhanashekhar. I'm going to present a paper. My topic is experimental comparison of glass and jute fiber with and without eggshell additive, reinforced hybrid composite. So the authors are Professor A. Ramurthy sir, myself Dhanashekhar, K. Velavan sir. Abstract. So composite nothing but it's a combination of two or more materials that will result a better property when which is used alone. And it is widely used in many applications instead of traditional applications because of its superior mechanical properties. So the applications of fiber reinforced composites are defense, marine aircraft, households, components, and etc. Right. So in this paper, we investigated the glass and jute fiber reinforced hybrid composite with and without eggshell additive with and without eggshell additive hybrid composite. First, we fabricated the glass and jute fiber reinforced composite. After that, we also fabricated the glass and jute fiber with eggshell additive hybrid composite. After that, we test the we conducted a mechanical test for both the laminates, and we compared the and evaluated the both the laminates. So here the objective is first we fabricated the glass and jute fiber reinforced hybrid composite and glass and jute fiber with eggshell additive reinforced hybrid. And after that we evaluated and compared the properties of mechanical properties of jute and glass and jute fiber with and without eggshell additive reinforced hybrid composite. So next fabrication process. So components requirements for making a fabrication uh, is glass fiber, jute fiber, eggshell powder or eggshell additive, epoxy resin, hardener, wax. Here we have chosen 350 GSM glass fiber, bidirectional glass fiber, and jute fiber also. It is also a bidirectional uh, fiber. Here, Excel we used, Excel additive we used, and epoxy. This epoxy resin and hardener, which is prescribed in the ASTM standards. We have followed as per the ASTM standard, and we fabricated the laminate by the hand layup technique. First, we prepared a mold, and we cleaned the mold with the help of abrasive paper. After that, we place the wax. We apply the wax over the mold. After that, we place the OHP sheet over the wax. Again, we apply the wax. The wax is made of glass fiber with a size of 300 into 300 square. Uh, After that, we apply a epoxy resin, and we rolled it by using the roller for a equal distribution over the entire surface of the layer. After the epoxy, uh, After epoxy resin, we place the jute fiber over the um, epoxy, and again we rolled it for the better bonding, equal distribution of the epoxy resin. So like this, we used 11 layers, that is 6 of glass and 5 of jute fibers. This is a procedure we, 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 we used to fabricate the glass and jute fiber composite laminate. And then second thing, we fabricated the uh, glass and jute with excel additive composite laminate. So in that, just we added excel additive in between the jute and glass fibers. That is the difference. So this is the after fabrication. This is the glass and jute fiber hybrid composite without adding the eggshell powder. Here, this is the second picture shows the jute and glass and jute fiber with eggshell additive composite. So after fabrication, we were conducted a mechanical testing. That is, we conducted 4 mechanical testing: tensile test, structural test, um, hardness test, and density test. So, and finally, we compared the results of all the tests. So in this graph, which shows x-axis force and y-axis represents the displacement. Here, the tensile strength for the jute and glass fiber is 14.54 kilonewton, and maximum tensile strength for the jute and glass fiber with eggshell additive is 15.80 kilonewton. As well as the ultimate tensile stress, we have calculated, that is 183.03 megapascal for glass and jute fiber hybrid composite. For glass and jute fiber with eggshell additive, we will get 182.19 megapascal. So the maximum the displacement which will be occurred in the that is in case of second one, that is glass and jute fiber with eggshell additive hybrid composite, that is 32. Without eggshell, the value the displacement value is 24. The corresponding force approximately 14,000. Next, we done a fractional test for both the composites. Which results indicated the maximum applied load for the jute and glass fiber hybrid composite is 1.47. Uh, in case of glass and jute fiber with eggshell additive, the maximum fractional strength we will get 0.47 kilonewton. So, which is which is lower than that of the glass and jute fiber composite. After that, it tends to decrease. So next we done a hardness test by using the hardness testing machine. We have taken a number of 3 trials for each component. So we will get approximately, that is the hardness number which is 69 for the glass and jute fiber without
Please speed up
considering.
your
Yes,
presentation, Mr. Dhanaseka.
yes, sir. And the Swiss 2 is 67 uh, hardness value. And finally, we done a density test. We will get a value of 1.50 grams per cc, and for the glass and jute fiber without considering eggshell additive. A glass and For a glass and jute fiber with considering the eggshell additive, we will get a value of 1.80 grams per cc. So finally, we conclude that the ultimate tensile strength in the glass and jute reinforced hybrid composite with eggshell filler is lower than that the glass and jute reinforced hybrid composite without eggshell filler. In case of flexural testing, the flexural strength, which is lower in case of uh, glass fiber and jute fiber with the eggshell additive, and hardness number approximately which is equal, that is only two hardness numbers only difference. So it is having approximately a same hardness number. And density value we compared, that is the density of the glass and jute fiber with eggshell, which is lower than the glass and jute fiber hybrid composite. Thank you, sir.
From the audience, any doubt related to this presentation, you can ask. So no more question means, shall I ask, Mr. Dhanaseka?
Yes, sir. Yes, sir.
Yeah, you are doing any research work now, PhD or any completed PhD?
Yes, sir. I'm doing now research, sir.
Where? Anna University or in
Anna University, sir.
who is guide?
So I registered in 2019, sir.
Who is your guide?
Dr. A. Ramurthy, sir, from Savita Engineering College, sir.
Oh, Savita Engineering College.
Yes, sir. Yes, sir.
Yeah, why you have selected this particular composites for research work? Any specific application you are minded of?
Sir, this paper is not related to my research, sir.
Oh,
Yes, sir.
so this paper is your research work or some other
Yes, sir.
students? Your research. So you
Yeah.
have conducted the 3 tests, tensile,
Yes, sir.
fractional, density, and hardness. Okay.
Hardness. Yes, sir. Yes, sir.
Yeah, we are which hardness? The micro hardness or macro hardness?
Micro hardness. Sorry, sir.
Huh? Micro or macro?
Sir, micro hardness.
Why you are
Use
did micro hardness? Any specific justification is that?
no, sir. I don't have an idea about that, because simply have taken that. Test.
And then you have did 3 common tests. Other than common tests, some more tests are available in the composites. Nowadays, because with the flexural test and this one, the open hole tensile test, have you heard about it?
Open? No, sir. No, sir.
Open hole tensile test.
No.
This another test. Suppose they were developed composites going to fashioned with other material. You have to make a hole. In that time, then the inner side, the whole diameter having some peeling or a delamination is uh, involved. It will create the adverse effect. So in that case, you have to identify the property as well as the quality. You have to do the test. Then
Okay,
you
sir.
can include that test also for your further research.
Yes,
And
sir. Yes.
also, And the DMA also we can done. Why you are not done DMA, dynamic mechanical analysis, and the
No, sir.
thermography?
This is a part of the work, sir. We have an idea to extend this paper, sir.
Yeah, because if suppose you publish a good journal,
Okay.
and these are the things are essentially required.
Okay.
Because
Okay.
basic test already you did, the
Yes, sir. Yes, sir.
advanced level it is needed. You have
Okay.
to concentrate on that. What
Okay, sir.
my
Okay.
advice, and you can I hand over to Dr. Siva Kumar.
Yes, sir.
Thank you, sir.
Dhanashek, sir.
Yes, yes,
Yeah,
sir.
your presentation is very nice.
Thank you, sir.
I have small queries, only one questions.
Yes, sir.
Uh, most of the peoples will be going for this combination.
Oh,
Why? I refer so many papers
okay, sir.
for the same jute and fiber composition. What's a general, any general principle or general rule will be there? Why
Uh,
going to choose this area?
that's why I added a eggshell additive for differentiate, sir.
Excel
We will.
additives. What's the main purpose of additives adding for this project?
Um,
What is
uh,
the advantage?
so I think it will improve the mechanical properties. That's why I think, sir.
In mechanical property, which
Uh,
property?
the
Any
strength,
specific property?
tensile strength and flexural strength, sir.
Tensile.
It is not actually done. It is not actually came from the testing, but because in
Okay.
a flexural strength, it is lower than the glass fiber, glass and jute fiber itself.
Okay, sir. Okay.
But in case of tensile strength, it is more than that of the glass fiber without considering eggshell additive, sir.
Okay, sir. Okay. Thank you, sir. Thank you.
Thank you, sir.
Okay. So, Mr. Varan, sir.
Yes, sir. Yes, sir.
Yes, sir. Next
Uh,
participant, sir.
Next, Bhuvneshwari ma'am, kindly present your paper.
Yes, sir. Am I audible, sir?
Yeah,
Yes,
yeah.
sir.
Yeah, it is audible. You can present.
Okay, sir. Good afternoon. My topic is review on deep learning for material synthesis and manufacturing systems. The introduction. The current scenario in materials and manufacturing systems made the traditional algorithms void and lead to evolution of artificial intelligence techniques to develop the systems involving decision making. One such technique which works the way human behave is deep learning, which made the machines smart, intelligent, and autonomous. The
Before
major
before presenting, you have to introduce yourself. 2 minutes. Okay. Hey, any presentation?
Yes, sir. Yes, sir. Sorry, sir.
Just you are in what you are doing, and I think most of the faculty or research scholars are not did this practice. Please, you tell about yourself, then you can proceed straight away. Okay.
Okay, sir. Start for that, sir. I am Bhuvneshwari, working as assistant professor in Coimbatore Engineering, KPR Engineering College, sir, Coimbatore.
Madam, first slide, please. A topic of the topic, please. First slide.
Then my
Topic.
topic is review on deep learning for material synthesis and manufacturing systems, sir.
Okay. 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 Carry on.
Introduction about the deep learning.
You are doing any research?
Yes,
PhD?
I am doing, sir. Yes, sir, I am doing.
What is your topic of PhD?
Metal matrix composite, sir.
Who is your guide?
My co-presenter is my guide, sir.
Uh,
Rajesh Kumar.
okay.
Yes,
Okay.
sir.
Then proceed.
Okay, sir. The current scenario in materials and manufacturing systems made the traditional algorithm void and lead to evolution of artificial intelligence technique to develop the systems involving decision making. One such technique which works the way human behave is deep learning, which made the machines smart, intelligent, and autonomous. The major beneficiaries of deep learning are healthcare, manufacturing sector. The further includes agriculture, retail, energy, education, and skilling. The attempt of mimicking the human brain to enhance the learning behavior of machine learning algorithms created a variant neural network or artificial neural network. The significant component of artificial neural network performs the certain computations to detect features or business intelligence in the input data is perceptron or artificial neurons. While coming to the artificial neural network, it consists of several layers like input layer, weights, activation function, hidden layer, and an output layer. Based on the number of hidden layers and feedback mechanisms, this could be classified as a single layer, multi-layer, and recurrent networks. While comparing DNN, deep neural network, with the artificial network, it contains several hidden layers like 1,000 layers. The contribution of deep learning architectures like CNN, convolutional neural network, restricted Boltzmann machine, autoencoder, recurrent neural network, the variants made the technology more embedded day-to-day life to be in pace of customer expectations. Deep learning outperforms the traditional machine learning algorithms by feature learning with transforming the data into abstract representations, model construction with non-linear combination of multi-layers and with training parameters jointly. The various deep learning models with variants, which is the key for the implementation of those models for various sectors, includes convolutional, restricted, autoencoder, recurrent neural network. So this slide explains the various models for deep learning. The first one explains the variational autoencoder network, second one convolutional neural network, and third one is restricted Boltzmann machine architecture. So rest of the slides will be explained by co-presenter Mr. Rajesh Kumar.
Thank you, ma'am. So good afternoon, everyone. I'm Rajesh Kumar, working at KPR Institute of Engineering and Technology. Sir, am I audible, sir? May I continue?
You are audible. You can continue, Rajesh Kumar.
Thank you, sir. Thank you.
You are a student. You are a assistant professor or associate professor?
So I'm an assistant professor, grade 3, sir.
Okay. And then where you did your PhD?
Sir, PhD at Anna University, sir. My guide is Dr. K.S. Amruthakadeswaran, retired professor of Government College of Technology.
Yeah, I know him very well. Okay.
Fine, sir.
Yeah, which area you did?
Sir, metal matrix composites, sir. Copper matrix composites.
Okay, copper. Okay. Proceed.
Right. Thank you, sir. So the current work, sir, the current work mainly deals with the consolidation of various deep learning techniques which are used in mechanical field, mainly for the damage detection, mainly for manufacturing systems and material behavior. And since this is actually an integration of computer science with mechanical engineering, and initially an attempt has been made to consolidate what are all the various studies that have been made previously during the recent times with regards to the materials and manufacturing systems. So first we'll see the deep learning for manufacturing systems. Few machine learning algorithms were usually used for the comparative research of application in machine tool wear forecasting, and many other new deep learning techniques or artificial intelligence based techniques like fuzzy logic, neural network, and genetic algorithms were explored for the possibilities of evolving novel techniques, schemes, and standards for decision support making systems. The main point in introducing artificial intelligence within the manufacturing systems is to make decisions, very fast decisions and accurate decisions, which cannot be taken by the humans. And some of the problems associated with the big data, that is the entire set of big data included in manufacturing system, is that it will have multiple coincidences within the measured data, feature space characterized with many dimensions and multimodal data expansion. And this particular hurdles of machine learning can be overcome by using deep learning algorithms. So machine learning algorithms are the primitive algorithms of deep learning algorithms, where in deep learning algorithms we'll get the feedback and we'll evolve the training model. The model can evolve with the training by itself. So the range of performance can be increased by using multimodal image text processing, natural language processing, and also the translation of data, image, and speech recognition inclusive in manufacturing systems. And deep learning renders an advanced tool for the big data analytics, which could handle high volume of modeling data, and it can also render an autonomous learning based on model features. And the deep learning based on various levels of abstraction. Deep learning uses non-linear processing of cascade layers, where machine learning uses only linear processing. And end-to-end optimization techniques is also used for the prediction and identification of hidden layers, whereas in machine learning it is not possible. Hence, from all these points, it is very clear that deep learning is having greater advantages for smart data-driven manufacturing applications using the same big data. And this points were taken from the paper authored by Wang, and this shows the smart manufacturing process cycle, which encompasses the various stages in manufacturing. The next review deals with the same usage of deep learning for the prediction of crystal structure. Since the material crystal structure prediction is very imminent these days, the deep learning can be employed for such prediction, and which does by using the normalized atomic fingerprints which were gathered from the crystallographic structure of the materials and with the structural topologies in a specific scale. And deep learning model possesses the statistical performance when used for the rapid identification of chemical structures and compositions, or even the combination of elements, which currently machine learning could not do. Machine learning could identify only the absolute elements, where the combination or relative elements could also be identified by using deep neural network models. And the prediction of crystal structure was dependent on the ability of DNN model to recognize the crystallographic site similarities and the possibility of an element to conform crystallographic topologies. So it could be clearly stated that deep learning methods or deep neural networks can be used for the prediction of material crystal structures, even when there is a difference between known composition and the accurate template crystal type, which machine learning could not do. So these points were taken from the paper authored by Ryan, and this shows the tree which uses deep learning methods to predict the crystal structure of the element. And next, the same deep learning could be used for material damage detection, which is very important because damage detection is very unavoidable, and many design principles are based on this damage detection. So damage detection can be done by using two ways, direct and indirect methods, where in direct method, material behavior is measured at normal conditions. The change of material behavior is measured at normal conditions, while in indirect detection, the response from an external excitation source is given to the learning algorithm, which is being trained by using those signals, and then the damage detection is being made. The best example for the direct damage detection is the detection of weld defects using radiographic methods, which are coupled with the trained DNN model, and the process became completely autonomous while using the deep learning algorithms. And as far as the indirect damage detection is concerned, subsurface flaws developed in carbon reinforced plastics were initially detected by ultrasonic non-destructive testing machine, and the signals were then given as an input to convolutional neural network model, which is a deep learning neural network model, and the training was done by using those signals. So this comes under indirect damage detection. So this has been reviewed and consolidated from the paper written by Masuguchi, and this shows the damage detection models by using microscopic images for both indirect and direct. So hence it could be consolidated like this. Since the fog and cloud computing are very much evolving, the augmentation of those process methods with the deep learning methods have become easier, have rendered easier and instant operational results. And deep learning could also be coupled with cloud computing, which controls the manufacturing systems utilizing the big data, where Industry 4.0 is completely focused upon. And deep learning strategies is not only used for material manufacturing applications, it is also used in additive manufacturing, distortion workpiece, since during additive manufacturing, when the aspect ratio is very high, that is the width to the depth ratio is very high, the distortion prediction can also be done by using the deep learning algorithms, so that accurate geometrically accurate parts can be easily manufactured by using additive manufacturing. And so far deep learning methods are using only high resolution images or the entire big data, but in future deep learning algorithms has to be developed which uses even low resolution images at times we want, or some portion of big data can also be used for revealing solving in real-time industrial problems pertaining to material synthesis, characterization and usage of manufacturing systems.
Okay, Mr. Dr. Dr. Rajesh Kumar,
Yes.
you have given the nice presentation on the deep learning.
Thank you, sir.
And, I want to know how they are used the deep learning through their productivity or any performance efficiency or any quality concept or any other labor efficiency to be increased. Anything has been adopted anywhere?
Sir, actually, while collecting literatures, we could find that only the Wang paper was Wang and the other Rayan paper was written in 2018. All the other literatures were written only in 2020 and not before that. Before 2018, we could not find any deep learning paper. Only machine learning was adopted, and all the authors invariably reported that machine learning practices could not be continued for any of these mechanical engineering purposes. But as you say, we couldn't find any literature pertaining to the quality or some other concepts that we could not find, sir. We are exploring further. We'll find in near future, sir.
For your suggestions related to the young researchers
Okay.
using this deep learning, what are the way we can achieve in the future in the manufacturing industry? You have to give any suggestions. You have to give. Okay, because you have did a lot of literature and survey, and finally you have given this and that. But
Yes,
finally, you have to give some idea
sure,
and
sir. Okay.
to young researchers, because deep learning is next generation dominating for additive manufacturing and other aspect, industry 4.0, like that. And
Okay,
how it is useful to the youngsters and the society. You have to
sure,
highlight.
Sure, sir. We'll expand the studies.
Yeah, you okay? Now you can do one or two lines related to that.
Sir, I couldn't get you, sir.
One or two lines you have to highlight this type of answers.
Oh, okay, sir. Sir, as far as this deep learning is concerned, one scope for expanding this deep learning is by using the normal mathematical models, because previously in all the literatures, they were using specific mathematical models using differential equations. They trained the neural networks by using those mathematical models. So one has to be very strong in the differential equation part in order to be a very good, in order to have a very good depth in deep learning methods. So by integrating the differential equations with the network models, we could develop a very better deep learning algorithms for any stream-wise applications we require.
And I need the application point of view from you regarding the manufacturing industry field. For example, your sales volume and product quality and rejection rate and the human resource utilization. In that aspect, you have to apply the deep learning. That is important, because nowadays the softwares are plenty of softwares are available. The optimizing the process parameters and other data and design aspects.
Yes, sir.
That aspect is already available now. How it is useful to in that aspect, that means related to the industrial engineering. Okay, that aspect, deep learning, how it is useful, you have to highlight like that. Okay, in future study you can concentrate on that.
Sure, sir. Sure.
Thank you. I hand over to Dr. Sivakumar.
Yes, sir. Rajesh Kumar, sir, very wonderful presentation, sir. I learned a lot of information from you, sir. I
Thank
have
you so
small
much,
doubts, sir. Only one doubt. What is the difference for IoT and deep learning? Any difference will be there?
sir.
IoT. Now, recently, IT sector people will be using IoT. In mechanical, go for machine learning and deep learning.
Yes,
You
sir.
have to club together in future.
Sir, I couldn't answer this since I'm not much familiar with IoT. I read more about artificial intelligence and deep learning alone, sir. Sir, I learn, sir. I learn and
Okay, sir.
let it incorporate, sir.
Okay, sir. Thank you very much, sir.
Thank you so much, sir. So thanks for your comments, sir. Thanks for your constructive suggestions. Thank you, sir.
Thank you, sir.
Next presentation, anybody is there, or that's all?
That's all, sir. One presentation, one person came, sir, due to network problem, is not able, so coming, sir.
Okay, then finish. Okay.
Sir, one person coming, sir.
One person.
Sir, Manoj Kumar. Manoj Kumar, kindly share your presentation. Manoj Kumar. Manoj Kumar. Manoj Kumar.
Hello, sir.
Kindly share your presentation.
Yes, sir. Gautam is on the way, sir. He is going to share the presentation, sir.
It's not coming. You only coming. not yet coming. We previously came and he told me that there is some network problem.
Just a minute, sir.
Okay, kindly present. Sri Prakash?
Okay, Mr. Valavan.
Yes, sir. Yes, sir.
I think people are not get ready. I think the time is wasted away.
Okay, sir. Okay. Okay, sir.
I think you can incorporate him to another session.
Okay, sir. Okay, sir. Okay, sir.
Okay.
Sir,
Thank you very
sir.
much for your coming, sir.
Thank you, sir.
Yeah, okay. Thank you, Anandal. I think I learned something from this session. The young researcher and senior researcher and junior researcher, they have presented a very well manner, and also the co-chair also is jointly giving them input along with me. So I thank one and all present here, and I hope the Sairam Institute of Technology is doing a lot of research activities to the industry as well as the society as well as the students, okay, researchers. I think I wish the institute to do more activities like that. I congratulate all the coordinators, and I convey my sincere thanks giving opportunity to chair the session. Okay, thanks one and all present here. Okay.
Okay.
Thank you, sir. Thank you, sir.
Thank
Thank
you.
you, sir.
On behalf of our SRM Early Engineering College, thank you for your accepting. Thank you for inviting for me for joining this session, chair. Thank you, Velavan sir. Very nice coordination. Your in your participants and chairs, session chairs also. Thank you for
Thank you, thank you, sir. Thank
Science
you.
Technology, sir. Welcome, sir.
I thank you all the participants present, sir. Thank you very much, sir.
Okay, sir.
Thank you, sir.
Thank you, sir.
முடிச்சிட்டீங்களா சார்? அதை ஸ்டாப் பண்ணுங்க சார்.